Welcome. This is week 5 of the Sausage Sports Club weekly update. Every week I talk about my progress on the game and how I'm feeling about it, what I'm working on, stuff like that. This week I have a lot to talk about, but also there's some stuff I can't talk about. The console dev stuff that I haven't announced the platform for. So don't expect me to be getting into too much detail about that. Anyway, a little background. I do this every week for 3 reasons. First reason is to help new developers, students, people jumping over from AAA into indie, just to see what it's like to work on a game alone and see me going slightly more insane every week as I get closer to ship. I do it for that reason. I do it for the obvious marketing reason of if I don't talk about the game, no one's going to hear about it, no one's going to know about it. And the third reason is selfish. In 10 years, when I look back on my process of making games and how I thought about making games in the past and my processes and stuff, it would be cool to look back and see oh, that's when I learned that cool thing. That was a fun time, or oh, I did a good job on that game at doing this one specific thing. I should try that again. So I do it for that reason too. With all that in mind, let's get into it. So this week, like I mentioned, there's some stuff I can't talk about, but the stuff I can talk about, I finished the character that I worked on stream somewhat on this week, and I'm going to show you what that looks like in game. This is Flop the Frog. Oh, my controller's unplugged, so I'll use the keyboard. He's obviously a frog character. Oh. Just like all other characters, he's got a big long neck. It's a floppy boy. Can't see it, but he's got a tongue in his mouth. We'll probably be able to see that during dialogue. I'm gonna add a blend shape of his mouth opening and maybe the tongue flopping out a little bit. See what happens there. But yeah, I'm really happy with how he turned out. I thought I was gonna have to make an entirely new rig to support his legs, which you probably can't tell because they're too small on screen, but they kind of angle outwards more so than a dog or a horse or the alligator, which I think the rig is based on Scout's rig and is used by the horse and the alligator, but I based this mesh off the alligator, so anyway, this is how it turned out. Pretty happy with it. I still gotta make the skins and stuff, the other skins, and I still haven't done hat placement on Flop, which would be an interesting thing, I guess, to go over at the end of the stream. Do that, and you can see my process for that. It's really just I go through every hat that's added in the game, and I have to manually set it up on every character, or I have to set up every hat manually on every character to get the placement right. But I made a little window, or a long time ago, to get that right. Yeah, so that's Flop. Let's move on. One cool thing that happened this week that I haven't done in a long time is I changed the physics controller. I changed how the player works and how the player moves and stuff, and added a new mechanic. And let me swap out to another character. Let's do Allie. Do Sombrero hat, which is totally unrelated to the mechanic, but the new mechanics are inspired by other really cool local multiplayer games like Towerfall, and what was the other inspiration? Oh, and Mario 64, which isn't a local multiplayer game, but whatever. So the new stuff, when you dash, previously when you would dash, you couldn't jump out of it. It would just you would just keep going, and your jump input would just be wasted or not used or whatever. And as I was playing, that wasn't noticeably bad or anything. It was just it just wasn't something I thought about. But in sitting down with a conversation with my friends Tom and John, we were just brainstorming like new mechanics that the game could have that would add depth and complexity, and we didn't land upon this specific one, but we had some cool ideas, and I was thinking about all of them and where they would fit. And I came up with this idea to add, to let you jump in the middle of your dash to like give you a boost to go even farther than your normal jump. And that's what this looks like. And like I said, it's inspired by Towerfall, which has the same idea of a dash jump, where if you dash like a frame or two after you dash, then you like jump super far. And it's really cool. It feels good, and it's like an extra opportunity to move fast, and it's a cool choice because it forces you to pick to sacrifice your safety for extra distance, extra move speed. And it's the same thing in Sausage, where if I dash and then jump, I'm really vulnerable to getting hit by a kick for another player and just getting like totally knocked away. But if I'm like trying to catch up to another player, it's like really valuable to get that extra boost of speed. So that one's really cool. The other one is the aimed stomp. Usually when you stomp, it's just like stop moving, and then you immediately go down and then hit the ground, and like a poof comes out, and that knocks people around you in a circle backwards. Now when you're in the air and you stomp, you kind of get like, you maintain your momentum so that you keep going in the direction you're going. And this may be a little hard to notice, or like doesn't seem like much, but in terms of the game, as it, like this as opposed to like that is a pretty big difference. Where if I'm chasing a group, or if I'm if I correctly like time my jump, I can dash and then stomp in between a player and like another player and the ball, and it'll knock the ball where I want it to go, and knock the player away from where I want the ball to go. And it's just like a good. It feels like you're making a play, or like making a tactical choice, whereas the previous stomp was like you could keep players away from a goal with it, or if there was just a huge pileup, you could knock everybody around. But it just wasn't, it wasn't that good. It wasn't that interesting of a choice. So now with the maintain momentum while you're dashing, it's a lot more interesting. And I showed Tom, and I showed John, and I showed our other friend Sebastian, and their feedback was a huge compliment, that it felt like the game always should have felt. And that's, as soon as I heard that, I knew like I'm definitely gonna keep these. These are definitely gonna add a lot to the game. Players are gonna like it. Before that, I was worried that these extra mechanics would add like extra complexity to the game that would make it harder for new people to have fun or compete. And I don't think that's true. I just think it's gonna give them like a wider. It's gonna like increase the skill ceiling of the game a little bit. Oh, my controller became unplugged. It's gonna increase the skill ceiling of the game a little bit, and it's gonna make skilled players stay interested longer, and that's gonna let like less skilled players get better because they'll be playing for longer. So it's just a good idea. Whoa. And I think it's kind of like Rocket League a little bit, where in Rocket League, if you're not good at the game, you can still have fun, but when you get good at the game and you notice the like really interesting like flight mechanics and like the amount of finesse that you can have in Rocket League, that like takes it to a whole nother level, and that's what I'm hoping these new mechanics will do. Yeah, so that's that. So I like those new mechanics. Another thing I did this week that changed up the gameplay a little bit, but mostly is just like helps with the readability, is, let me load the overworld, is I redid the art of the coins, which previously were just like basically like a default camera zones. It was basically a default like Maya cylinder, and I put a texture on it. Let me see if I have a picture of it. Whoop. I did not take a picture of the coins. I don't really feel like reverting to a previous version, so I'll just show you the new stuff. Bonk. Okay. You know, I probably have the old model. Okay, yeah, I have the old... Oh, what's that? What the fuck? There we go. Here's the old model. It's just like a default cylinder. Here, yeah, okay. Here's what the old one looks like versus the new one. Obviously, the colors are slightly different, but 5 coin. Yeah, so this is the old gold versus the new gold. Old silver versus the new silver. And fuck. Old bronze versus the new bronze. And this had bugged me for a while just because the previous one had like this professional, like it might literally be Times New Roman, like professional newspaper font, and it just was like way too professional, and it looked like to me it looks like it's trying to be a realistic coin and just like being bad at doing that. So I wanted to make something that looked more cartoonish, looked more like taking what the idea of money is and like putting it in a cartoon world instead of just like trying to make a bad looking attempt at a realistic coin. So that was fun to work on. We'll come back to the coins when I talk about optimization. So let me delete that so we don't get any weird errors. Also gonna get rid of those light probes, gizmos. I'm not sure how they got turned back on. Oh man. Okay. Next thing to talk about is optimization. I did a bunch of this week. I was trying to get a build ready for one of the console platform holders, and I just needed the game to run better on the platform. So I just did a bunch of profiling and looked at a bunch of code and looked at the profiler a bunch and optimized and made builds, and it ended up being a really productive like 4 days of just like going at it, trying to make everything better. And the end of it was a really terrible all-nighter to just like get the build ready and make it as good as I could, and it sucked. And I don't recommend doing that if you can help it. Okay, so let's just get right into it. So we're gonna load into one of the maps, do Bug Museum, make a mode select. So as you might know if you've watched the streams before, in Sausage there's instead of like a mode select menu, there's a mode select like level. You load into the level you're gonna play in, and you walk around. And each of these trophies is a mode that you want to play. And when you walk up to it, there's like this UI pop up, and it tells you hit X, and then you like hold the button, and it fills up, and then you go play the game. So that's all cool. It works well. But on the target platform, when I would do this, I would walk up to the thing, and there would be a 50 millisecond hitch as a new font atlas is being generated, and that's like a crazy amount of time for the game to hitch, all just like in the mode select like this. That's crazy. And not only would it happen, like it wouldn't just happen on the first approach of one of these things, it would happen every time I like went between two of them. So if I walked up to paintball and I walked away and then I walked back to paint, it wouldn't happen. But if I walked, unplug the controller again, sick. But if I walked to sumo and then back to paint, that would do it. And what I found out was, in Unity, if you're using a dynamic font and you have wildly different font sizes in your game, or even slightly different, Unity generates an atlas like a font atlas, which is just like a texture full of like every character in the atlas, and it does that for multiple sizes, if it's appropriate. But what was happening to me was I was using, for each of these pop-ups, I was using, and I'm still kind of using, the best fit option in the UI text component, which if you're a Unity programmer, you probably know that will like change the size of text to match the box that it's fitting in. So like paintball here has like each word is like slimmer than like not sumo, than capture the flag, or I guess sumo is the best example. Sumo is a really short word, so it can get scaled up really big to like fit the size of the rect, the text rect that it contains. And so it would do that. It would like, to fill the box, it would change its size to be like, let's say 10 instead of 8 or 7 or whatever. And so when I would do that, I would walk between one to the other. It would look at my font atlas, see, oh, we only have size 6 and 7, or just 6. I'm not sure the internals, if it actually does multiple sizes or what, but it would see, oh, we don't have the size that this UI text is asking for. We need to generate it right now. And it would 50 millisecond hitch, and that was completely unacceptable. And so I searched the forums, looked through that, and found out that this is a solvable problem if I convert to not use dynamic font, if I don't use best fit, if I third option is switch to TextMesh Pro. That's what I ended up doing. The reasons I didn't do the other thing, that I know that sounds like a ridiculous like overreaction to the problem, but I searched through my project and found everywhere that was using best fit, and it was a bunch of places. And then I searched through the project and looked at all my fonts, and every single font, which isn't that many, is using dynamic. And if I turned off dynamic, then I couldn't use best fit. And if I turned off dynamic, the font would just get like fuzzier and look worse. And so I was like, okay, that's really terrible. What if I like, and then once I decided, okay, that's impossible for me to like go fix that issue, or not impossible, but really annoying to do. I couldn't do it that night, which was the night before this build was due, and it was already very late. So then I saw, oh, TextMesh Pro totally solves this issue. It's a way more efficient solution than Unity's built-in text, UI text. And so I was like, oh, well, TextMesh Pro is like $60. I don't really want to do that if I don't know that I can make it work tonight or at all with the project, or if it's not compatible. And then I heard on Twitter that TextMesh Pro is now free. Unity bought the asset, which for one is a huge claim to the quality of the asset, that Unity would buy them, and which I assume means that they're going to try to integrate it into Unity if they bought it, but at least they made it free on the asset store. So that was really cool. So I spent a few hours. I made a tool that would iterate over the whole project, replace every text UI text component with a TextMesh Pro UI component, like copy over all the settings, like font size, font color. I have like a drop shadow on all my text. Not like the shitty drop shadow, like a solid blocky drop shadow. And I just went over everything and did that, and the tool did its job really well. It replaced all those components, but then everywhere in the game in code where I've referenced a text component just like lost its reference, unsurprisingly. And I also had to manually like go through and replace any of those text component references in code with like the TextMesh Pro UGUI, whatever. That was a bit of a pain in the ass, but as you might know, if you're a programmer, trying to find and replace the word text in your entire project, which is for whatever reason what Unity decided to call the UI text component, is hard. This is bad, pain in the butt. So I had to manually go through and replace that stuff. But then it was like pretty straightforward, and I'm still finding bugs from it. So, and I have to figure out again how to make my dialogue bubbles correctly, like Regan text with like each scaling character, which looked very nice. But then I broke it with TextMesh Pro. So that alone, not only did it fix, like integrating TextMesh Pro, not only did it fix that one performance issue, it just made the like every few frames in the profiler I would see something related to generating a font atlas or like rebuilding canvas related to text or whatever. And you know, all that stuff is just gone now from the profiler. It's in there, but it's not one of the high CPU usage things. So that was cool. I recommend TextMesh Pro. It's cool. It looks really good. They use signed distance fields for their textures, and it's just really cool. Oof! I just opened chat and heard my own voice, so it's terrible. I'm gonna look up picture. I'm not gonna explain signed distance fields actually. Okay, so that's TextMesh Pro. That was cool. I recommend doing that. The other really big win for collision in the game was, and I've done this before and I'll probably do it again, is this big old matrix just like going through. When I started optimizing stuff, my matrix was smaller and more things were checked off. There were more crossovers. And as I was going, I realized, you know, there's a lot of, specifically in the aquarium, there's a lot of triggers that are just like pretty big and are searching a lot of the map. And if I disable them or put them on layers such that the physics system only like checks the triggers versus the things they could potentially hit, then I'm just gonna like, you know, and I'll show you the like collision, the physics profiler, because that's interesting. Yeah, but if I change the layers such that the trigger where the squid tentacle is looking for players or balls to like touch, if it is only on the collision layer, if it's only marked to collide with those layers of dynamics, then it's just gonna not, I'm gonna have way more or way fewer overlaps with like the ground and rocks and the goal and moving platforms and other tentacles and other tentacles like triggers. So what was I gonna show you? Oh yeah, I was gonna show you the, yeah, so the tentacle, you can see here, it's a bunch of stuff going on. So for one, we've got this block on each of the tentacles. The block detects platforms, like moving platforms. So if, as you can see, there's on this side there's a tentacle, on this side there also is a tentacle, but it detected that the platform was about to intersect it, and so it like sunk into the water, and you'll see it pop back up here in a second, and this one dropped down. Yeah, so this box trigger does that. It's previously it was sensing everything. It was overlapping with the ground and the crabs and players and other tentacles and just like crazy tons of collision contacts. Now I remember what I was going to show you. Oof, give me 1 second here. Okay, and we're back. Okay, so you can see here, Unity's editor has a profiler. It's really good. This is what most people use it for, the CPU usage, but you can also use it for physics, and its physics capability is a little limited. It would be nice if I clicked on this and it showed me like, in the same way that the rendering paths view shows me like where expensive shaders are, which apparently is like my whole fucking scene. That's cool. Anyway, in the same way that view shows expensive shaders in red and then everything else in like yellow, like orange, yellow, green, it would be cool if in the physics view, when I clicked on this physics thing, it just like showed me all the colliders in the scene and colored them by like how much trouble they're causing, how many overlaps they have, and you know, that would be very useful. But what we get instead is how many active dynamics are in the scene, how many kinematics, how many static colliders, how many trigger overlaps are happening in this frame, how many rigid bodies, and that includes both kinematic and dynamic. We have 69 active kinematics, nice. An active, I believe what active kinematics is describing is kinematic rigid body. That's a rigid body that's marked to stay still, that's being moved that frame by your user code, or probably by your user code, or like the animation system or something. And that's an expensive operation, but is completely required for the game. Yeah, I bet that is what that 69 number is, because the tentacles each have like maybe like six of those kinematic rigid bodies moving every frame. So that makes sense. So yeah, when I started this optimization process of like looking at the layers and like what they're hitting, and another thing I did with the tentacles is when they go underground, when they're hit by the platforms, they disable themselves when they get underwater. Like they just turn off, because like why would they need to be on? They don't need to collide with anything. They shouldn't even be registered in the like collision matrix of things that need to collide. It's just wasted checks, because it's off, it's gone. So when I started to do this, instead of being like maxing out at like 400, which I think, and you know, if we get more players in here, if we got 8 players in here, we would get higher, probably more like 500-600. But when I started doing this, it was over 1,000. It was like 1,400, 1,500 was like my bad case, and that's a lot. That's like way more than it needs to be, as you can see here. Constraints also is like 800, 900, and thanks to just changing physics layers, you can get that stuff way down. Unfortunately, I didn't like take a before and after pic of like performance and like frame time of everything, and I wish that I had, and I might go back and do that eventually. But that was probably my number one, just like made everything better when I did that. So I can talk more about that in the future if I do more of that work, and if I go back and do like a before and after. But I'm gonna move on for now. Another not as big as I expected improvement, but still pretty good, is limiting how much I raycast based on like anything and everything that I can do. Like meaning like any time that I don't need to be raycasting, or any time that I can cheese it, do it. Notably, the changes I made there were in the physics like controller of the character, in which I need raycast to detect the ground every frame, or every so often, to determine whether I'm allowed to jump. If I'm on the ground, I'm allowed to jump, so we need to check that pretty often. And so some things I was able to change there to just get rid of a bunch of raycasts, over 50%. So one first thing off the bat, every player in the game, like every human character, is assigned an index, a player index. For every even player, I say only do raycast for the ground on even frames. Boom, cut in half. And similarly, every odd player do odd frames. That's just a 50% cut, which was great. Then I realized, you know, I don't always need to do them anyway. If I've just jumped, if I'm, you know, in my jump arc of my character, if I'm in the up half, there's no ground that's gonna like follow me up. It doesn't make sense. And even if it did, I'm moving up, so I don't need to be checking if I am allowed to jump again. And so that was another. That's a pretty common thing to do in a 3D platforming sports game, is jump. So that's another big savings. Another time during the dash state, when the player dashes, they get like a quick burst of movement, and the newly added dash jump mechanic, or the long jump where you can jump out of a dash and get a boost, or the new pound dash where you like do a diagonal pound instead of the straight down pound. So I didn't used to need to know. I didn't whether I was on the ground or not during a dash, but now you do need to know for those. But luckily, you don't need to know every frame of a dash. You only need to know on the frame where I press A again to either jump out or to do a diagonal pound. So I just like took out the grounded check from dash and put it into the logic where I check if I'm going to jump during a dash or pound during a dash. And that was those are basically like so I did a 50% cut with the even frames, and then I did out of the time you're playing the game, I would say most of your time, or around half of your time, is dashing or jumping. I cut the number of raycasts during the jumping state in half, because the first half is you jumping up, and you just don't raycast then. And then during the dash, you almost don't raycast at all the whole dash. So it's I don't know the numbers. This isn't an accurate number exactly, but I would say it's like a 70% reduction in raycast per frame, or maybe more. That was huge. And just a few easy things. If I like just some things that are easy to decide, just thinking about how the game works and whether I need to raycast or not. So that was cool. It's another big optimization. Another one that I've talked about on Twitter a little bit is how slow projectors are in Unity. This is it's not built in, but it's included with standard assets, so it's basically built in and Unity approved. But it's like, I think I have them in the project still. Blob Shadow. So this is what it looks like. It's like you get like the camera gizmo, and it like draws. It's got a frustrum, and it draws like a blob on the ground wherever it hits. But what Unity doesn't tell you is that when you do this, it just like adds like crazy numbers of triangles to your scene. Just this one blob shadow is 3,000 triangles. What's up with that? And also 4 set pass calls. Like, what the fuck? And what's happening, what I think is happening, is anything that the frustrum hits is just like the mesh. The whole mesh is just being drawn again and being like stencil buffered out, except for the like this like little shadow bit, which, you know, if your game has polygons, if your game has like a fair number of polygons in it, which mine does, according to the profiler here, it's in the hundreds of thousands, and that's mostly because of like lighting and shadows and stuff. But anything that it hits, it's just gonna like double how many. It doubles the number of verts that or the number of triangles that the graphics card has to draw. So fuck that. And this is kind of a big hit for me to not have these, because in the game it's like really important to see where balls and characters and these ladybugs are gonna drop, like where they're gonna hit the ground. And in games like Rocket League or another indie kind of arena sports game, Real Winners, it's really important to know where the ball's going to drop so you can be there. And in this game, it's similarly important, but I can't use these projector shadows because they're crazy inefficient. And my directional light in the scene, wherever that is, light, oh, it's just light. Wherever my directional light in the scene is, you'll notice that it's not straight down, and that's an artistic decision. So I get interesting dynamic shadows that or not, they're not dynamic, they're baked, except for the like characters and dynamic objects, but I get shadows that are more interesting than if the light was just straight down, like high noon, you know, that it's more interesting that way. And I'm not willing to compromise that. So that means my shadows that as they appear in the world aren't representing where the player's gonna fall, and that feels weird. And so I'm kind of at kind of between a rock and a hard place of like, do I like make new tech of these blob shadows? Do I have to do that myself, or do I make an artistic compromise of like changing the light direction so that you just know where you're gonna drop through that? Or do I bite the bullet and use these blob shadow projectors? Like I can't really see that happening because they're so inefficient. So that's a big frustration. So that's my rant on blob shadows, I guess, on projectors. Another really big win that I had is in setting position and rotation and velocity. I had heard that these were really expensive operations. Notably, there's a talk that Play Dead Games gave about how they got Limbo to run at 60 FPS on PS4 with no stuttering. And that talk is great. They talk about a bunch of crazy stuff. Notably, they have source access to Unity, so they can change the engine, rebuild it, fix bugs, like change the rendering pipeline if they want. They can do whatever they want. They can just change anything. And they didn't change everything, but they did like fork Unity pretty early and like make a lot of changes of their own. One thing that they mentioned is in that talk is that set position and rotation are ridiculously expensive because when you use either of them, Unity has to go through the entire hierarchy of that object and like update, has to do all the matrix multiplication to get all of the children to like be updated, to update their local or update their world position such that their local position doesn't change, you know. And that's like, if in my characters alone have like probably 50 sub-game objects on them, and that's 50 matrix multiplications to get them to the right, to get each of those to the right spot. So and the specifically the useful thing that they mention is if you have a function from which you can set position and rotation together at the same time, then you don't need to do that 50 times matrix or however many times matrix multiplication twice. When every frame you're gonna do these same two, you can set them both at once, and that literally cuts your performance or cuts your CPU time for that operation in half if you can use that function. And the really messed up part is that in Unity at that time, that function wasn't accessible to the public user. It was like an internal function that only Unity could use internally. They've since exposed it, as I think as a result of directly being called out in this talk, which was really funny. But I assume it's like their engineering team didn't realize how expensive that operation was, and that's why they didn't expose it. But who knows? Anyway, getting back to Sausage Sports Club, I went through the whole project, and in the profiler, eventually got down to this is like the biggest bottleneck. This is what's taking up so much time, and I added. As you may know, you can add into Unity profiler. I'm gonna pull my window over here. You can add profiler.beginSample like this. I should probably take these out, but I added, I don't know, like 30 of these to the project just to get like every granular level of detail about performance, and all of the spots that ended up being the most expensive. All the spots that ended up being the most expensive were spots where position or rotation were assigned, and notably in a lot of places I would do something like this, where I would say transform.position equals something, and then on the next line I would do transform position plus equals other thing, and sometimes it would be 3 of those, or it would be 2 of those for position and then 2 for rotation, and like that would, in some cases it was like quadrupling how long that operation would take when it would just need to be one thing. And once I upgrade to a version of Unity that has that set position and rotation thing exposed, I'll half it again, so that'll be huge. That's enough about that. Another recommendation I got from my friend David is to fix a specific mode in the game where there are lots of physics coins spawned all the time, and those are object pooled, which is an optimization I did a long time ago, and that's pretty important. But currently, when I create them, they use physics to like get some velocity, like plop on the ground, and then bounce a little teeny bit. There's tons of drag, so they don't really bounce that much. But they would bounce to a stop and then settle and then like disappear after 5 seconds. And all of these, of which there can be 50 plus at a time on screen, are physics objects. And previously they were like on a weird collision layer, so I was able to fix that a little bit. But it's still just very expensive to have 50 new dynamics added to the scene after there are already, as you can see here, there's already like 80 dynamics and kinematic, like active kinematics interacting. Now add 50 more to that and it gets really bad. So what David suggested is that instead of using physics, I just calculate like a physics parabola, like an up and down and where it lands, and just like use math instead of physics, so that all this collision's not happening. And also that allows me to remove the trigger from the coin, which would just collide with everything in the scene and other coins, and just use like distance from the 8 players, which even if for every coin in the scene, if I iterate over all 8 players and do a position compare every frame, that's still not that much. It's like 50 times 8 is what? It's less than 1,000, which is getting up there, but it's not that much. So, and I could even partition that over frames, like do it every other frame for even numbers of coins or something, or do it every 4th frame for every 4th coin, So that's going to get super cheap. I haven't done that one yet, but I'm pretty sure it's going to be a big win. So that's one. The last one is I'll load soccer just to see, just to give you a little bit of visual. But in soccer mode, in sudden death, as you may or may not have seen, the balls would keep spawning until somebody scores a goal. And previously, for whatever reason, until a few days ago, I didn't set a limit on that, so it could literally be like 10,000 on screen. That wouldn't happen because your computer would freeze up and crash the app, but that was possible. The app would eventually just spawn so many balls that your app would crash. And so limiting that to a reasonable number was just like made the mode workable. So that's a majority of the optimization that I can talk about, and I hope that is useful. My nose is itchy. Have you noticed? Yeah, Ryan Miller. It trigger detection probably would be less expensive, except that they're like doing it in a scene. If the layers aren't correctly aligned, I would be comparing distance against every object in the whole scene, so maybe like 50 things instead of 8. And if I do the thing I mentioned of partitioning it over you know, if I do every coin only is affected every 4th frame, then, you know, yeah, for sure. And that could be something to play around with, but that's all I got for today. I think I'll talk about optimization again in a future week probably, because I still have more to do to ship the game. Yeah, I've been really bad about doing benchmarking. I just kind of fix the problem and then don't. I find a solution that works and I don't like seek further solutions until it's needed, which might be the bad game developer way of doing it. Anyway, I gotta end this stream early and not do some work. There's a going away party for a friend happening tonight. But I hope this was useful, and I'll put up the like video on demand of the stream, so others can check it out. And with that, I'm gonna dip. So thanks for stopping by. Glad it was useful for you, Ryan. Cheers.